Okay, here's section 1.4, and I need to make a correction, I believe, on the definition of a boundary point. Of G. Okay, I had said I was thinking of a closed set when I wrote it down and didn't look that carefully at the text and so forth. And then as I looked further at the text and was looking at other definitions, I thought, well, gee, they never actually define the boundary point quite like I expected. And then I looked back and I thought, oh, they did. I just didn't state it the way I should have. So what did I do wrong? I had said a point, and I'll use a B this time since that's what they used, a point B in G, okay, in the set. Okay, that was wrong. Okay, because when we talk about the boundary of a set, the boundary points don't have to be in the set. So, right, or I could do it W-R-I-T, but R-I-G-H-T, but anyway, right, so a point B element of the complex numbers is a boundary point of our subset G, if again, it's the same thing now, every open disk centered at B, so every DBR, every open disk centered at B contains a point in G. Okay, so what was the difference? I had drawn something like this, and, I took that point and I said, yeah, that's the boundary point. Well, sure, yeah, it still is, but I could have drawn, say, my set like this, where what I'm saying is the set doesn't quite include that line. So it's, some rectangle again. But if, here I could take a point B and, there I'll take a point B. Then this B, even though it's not in G, so I'm going to say not an element of G, and this one is an element of G, these are both boundary points. Okay, because as I make those open disks, this still contains some elements of G. So it's where you would draw the boundary if you didn't actually have the boundary there. So, for instance, the boundary of DAR, an open disk centered at A of radius R, is the circle AR. Okay, so this was a totally open set, did not include the circle itself that contained everything, but then its boundary is that circle. So sorry for that mistake, but hopefully that has corrected it.